Hey guys, Taste here from the Code with Taste channel. Today we are going to be looking at structs. Okay, so structs are value types like ints and bools. However, we could use them to encapsulate data and related functionality, similar to the way we do with a class. Okay, so we have this person class here. It's obviously got all its members. It's got two private fields. Constructor to initialize these fields, and then a method to obviously print some information to the console about these fields. Okay, so I can transform this class into a struct, okay, by using the struct keyword instead of the class here. So I can do that, and it's not throwing any errors. So basically it looks pretty much like a class, acts like a class as well, because I can new it up, initialize the fields, and then print to the console just like I would do a class. So you can see here, new person, initialize the fields, print information, and when I run that, I get the information as I expect to in the console. Okay, so what's the difference between the two? What's the difference between a struct and a class? And why would we use the struct instead of a class? So let's look into that. Okay, so well, one of the differences is that a struct is a value type, whereas a class is a reference type. And value types are stored in a memory allocation called the stack, whilst reference types are stored in a memory location called the heap. Now I'm going to go into more details on that in another video, but basically let me give you a simple example so that you get the idea. Okay, so let's create two int variables, which are value types, obviously. Okay, I'm going to print the some information to a console. Okay, so we've got two int variables. One is set to 10, and then the other is set to I. Okay, so it's just copying I basically, and then we print that to the console. So let's see what we get. We should get I equals 10 and J equals 10, obviously, because J equals whatever I equals. Cool. So this is how it appears in the stack. So that's how it appears in the stack. So we've got we've got a stack here, which is the memory allocation, and heap here, this is the whole memory. And we've got I, and it's storing its variable, or its value, sorry, of 10 in the stack. And the same thing with J, is storing its value of 10 in the stack. Okay, cool. So let's head back to the Visual Studio, okay? So now what we want to do is we want to change I's value to 20. And let's see what happens. Okay, so let's put the code in for that. Let's get rid of that, place that in. Okay, so as you can see there, after the last console.write line, we're adding line of code there to change I to 20, and we're printing the result there. So what do we expect? Obviously we expect I to be 20 but J to be 10. So these were the original values, and then after we changed I to 20, these are the outcomes. So I is 20 and J is 10. So how does that look in the memory? Or how does that look in memory? So let's have a look. So basically we've just updated the stack and changed I to 20, but obviously J is still equal to 10. So nothing unusual there, nothing special there. What about reference types? Well, let's have a look at that. Let's repeat the same scenario with a reference type. So let's create a simple class called person. Okay. And then what we're going to do with that person class is we are going to new up two instances of person 1 called and person 2, and we are going to set the ID of person to 1 2 3 4, as you can see there, and then we're going to copy person, the object of person, or the reference of person, sorry, to person 2, as you can see there, and then we're going to print out person 1 ID and person 2 ID. So what do we get? Let's have a look. We'll run that in the console, and we get 1 2 3 4 for person 1 ID and 1 2 3 4 for person 2 ID. It's what we expected, right? Okay, cool. So now let's have a look at how that looks in the memory location. So, whoa, something different. So as you can see here, the reference person 1 and person 2 is stored in the stack. So that's this. This is stored in the stack, and this is stored in the stack. But the object that it points to, okay, let's go back to the object that it points to is stored in the heap. And so because we set this reference to this person2 to equal this reference, it's basically pointing to this memory location in the heap. So they both share the same memory location. So what happens when we change the value of one to another? So let's try that, and let's put some code in to do that. Okay, but I'm sure you guys are already guessing what's going to happen, obviously. So what we've done here is we're changing person2 ID to 0. So before it was equal to 1, now we're changing it to 0. What do you think is going to happen to all of the person1 ID? Let's run it and see. So as you can see, both of them have been changed to 0, okay? Not just one. And why is that? Well, it's if it's not obvious, then when we go to the memory location, it will become obvious. When we changed it to 0, what we did was we changed the memory, the object in the heap to 0. But both of these objects are both pointing to this location in the heap, so they both get affected by this change. So okay, so that pretty much says that value types like structs hold their memory, their value in memory. So structs hold their value in memory, whereas classes hold their value in the heap, or they hold they are reference types, so they reference to an object in the heap. Okay, so another difference between a class and a struct is a sealed is sealed, so it cannot be used as a base class. So I'm going to give an example of that. So where we have a struct and we cannot inherit it, as you can see here. So we just simple struct. It doesn't do anything. It hasn't got any members, but it's a struct, and we're trying to basically use it here as a base class and inherit it in this person class. And we can't do that. It says person cannot derive from a sealed type of account, which indicates that a struct is a sealed type. So I can't do that. But a struct can inherit from an interface. So let's do that. Let's draw up an interface. Let's give an example of that. So we've got these two here, and we need an interface. So let's throw one up. Public interface iPerson. Cool. And as you can see, we're not getting any errors because they can both inherit, a class and a struct can both inherit from an interface. Okay, cool. So when would we favor a struct over a class? Okay, well, Microsoft says when we are working with small data-centric types that have little or no behavior, preferably with its members being value types, is when you would is when you'd get the most benefit. Okay, .NET uses structs for ints and bools. So let's have a look at that just to prove that they do. So if we've got an int here, if we go to definition, right click and go to definition, you can see that an int 32, which is basically an int there, is a struct. So .NET uses that as a struct. And then also we can go back and check bool as well, and we should see that boolean, if we go to definition, is also a read-only struct here. Okay, cool. So they both use it as .NET uses it as a struct as well, or uses a struct to create a bool and a integer. Cool. Although I disagree with the fact that there's little behavior. It looks like a lot of behavior here, but hey ho, we won't get into that topic right now. Cool. Okay, so now let's give an example of when to use a struct. Okay, so let's create a struct and an identical class to show when it might be better to use a struct. Okay, so cool. So we have these two accounts. So one is types. One is an account struct. Okay, and the other is an account class. Okay, so obviously they're exactly the same except one's a struct and one's an account. Okay, so they have an account number, which is an integer, a sort code, and a balance, which is a decimal. So these are all value types that they contain. So kind of keeping within that rule of what Microsoft said, and there's little to no behavior. There isn't any behavior in both of these types. Okay, cool. So let's new them up and print something to the console. Okay, so let me copy the code in to do that. Save us time. Cool. So we're newing up the struct, and we're setting the balance to that value, and then we're doing the same thing for the account class, and then we're printing out the results to the console initially. Okay, so let's see what we get. So the initial struct balance is that value, and then the initial class balance is that value. Cool. Okay, now let's create some methods to modify both these values. Okay, so we'll create these two methods. Add bonus for struct and add bonus for class. Okay, I don't know what's going on here. There should be account balance, and there should be account balance. I don't know why I created these spaces here. Cool. So these two methods there, and then okay, let's invoke them, and then print out something. Print out the balance after they've been invoked. Okay, so let's put in some code to do that. Okay, so basically what this is going to do, let's go through it first of all. Okay, so we've got these two methods here that basically, okay, so let's start from here actually. So we've newed up our different types. We've printed the balance to the console. Then we've left a little space here. Then we've invoked these two methods, and what they basically do is add 500 pounds in this case, I guess, to the balance, and then it prints out the balance to the console. So you can see it doing one for both. One takes an account struct and the other takes an account class. So they're both doing the exact same thing. Okay, and then once we come out of these, once we've invoked these two methods, we then come out and leave another space, and then we console.writeLine the balance again. Okay, so now let's run this and see what happens. Okay, so let's see. So the initial we get is this value, which is exactly the same. And then when we go into the methods, which add a bonus, you can see it's exactly the same again because we've added 500. So it's doing the exact same thing to each of them. But when we come out of the methods, look what's happened. So the struct is still the same as the original balance or the initial balance, but the class has been changed. Okay, so you can basically see that the struct balance goes back to its original value after the method, whereas the class stayed modified. And obviously you now know why that is. It's because we're passing a copy of the struct to the method. Okay, whereas so that the original struct doesn't get modified. It's just the copy that we pass into this method that gets modified. Okay, but as you saw, the class got modified because we are passing a reference to the memory location into this method. So what we modify will also modify the original object. Okay, so what that tells me is this example is in this example is basically that if I don't want to modify my original object, when I pass it into a method, and that method does modify the object, then I would obviously need a struct in order to do that. Okay, and that basically brings us to the end of this video. Please look out for more videos on the channel. I hope you really enjoyed it. If you did, smash the like button, subscribe to the channel for more videos like this, and I'll catch you soon. Have a great day, guys.